This is SpaceTime, Series 28, Episode 12, for broadcast on the 27th of January 2025. Coming up on SpaceTime, the origins of fast radio bursts are back in question. Is the red planet Mars still geologically active? And Southern Hemisphere sky watchers get an astronomical treat. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A surprisingly new discovery is raising fresh questions about the origins of mysterious deep space blasts of energy known as fast radio bursts. Fast radio bursts are sudden high-energy flashes at very specific wavelengths, lasting just a few nanoseconds and originating at cosmic distances. But in that brief space of time, a fast radio burst, or FRB, can release more energy than 500 million suns. The first FRB was discovered back in 2007 in data from the Parkes Radio Telescope in the central west of New South Wales. Since then, thousands more have been detected. Some appear to be singular events, occurring just once at a specific location and then never again, and that suggests they're being caused by some sort of cataclysmic event, such as an exploding star called a supernova. But astronomers have been detecting more and more fast radio bursts that have repeated from the same location over and over again, and that suggests a very different cause. Feeding black holes, glitching neutron stars, and highly magnetized neutron stars called magnetars have all been suspected. And it could be that all fast radio bursts are repeaters, with some just a lot more active than others. However, new observatories, which are able to better pinpoint the locations of these events, have now raised questions about the hypothesis that they're being caused by feeding black holes, glitching neutron stars, or highly magnetized neutron stars called magnetars. Astronomer Calvin Leung from the University of California was excited last year to crunch data from a newly commissioned radio telescope to precisely pinpoint the origin of a fast radio burst called FRB 2024-0209A, which was emanating from somewhere in the northern constellation of Ursa Minor. Leung hopes eventually to understand the origins of these mysterious bursts and use them as probes to trace the large-scale structure of the universe, a key to the cosmos's origins and evolution. Now, he had written most of the computer code that allowed him and his colleagues to combine data from several telescopes in order to triangulate the position of a fast radio burst. However, his excitement quickly turned to perplexity when his collaborators on the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, turned optical telescopes onto the site and discovered that the source was actually in the distant outskirts of a long-dead elliptical galaxy that by all rights shouldn't contain a magnetar, the very kind of star thought to produce these bursts. The galaxy, which is more than 100 billion times the mass of our Sun, is located some 2 billion light-years away, and it's around 11.3 billion years old. So any magnetars in this ancient galaxy should have disappeared long ago. Now, this isn't the only fast radio burst to be found in a dead galaxy. The burst's location is surprising. Galactic halos are usually populated by the older stars, and so this raises questions about how such an energetic event could occur in a region where no new stars are forming. The authors have been developing a series of 3 companion outrigger radio telescopes associated with CHIME in order to further refine the location of the burst. And with this new precision, optical telescopes can quickly pivot to identify the type of star or star groups, globular clusters, spiral galaxies, whatever, that are producing the bursts, and hopefully identify the actual stellar source. Of the 5,000 or so FRB sources detected so far, 95% have been detected by CHIME. But few of those have been isolated to any one specific galaxy. And that's hindered efforts to confirm whether magnetars, or any other type of star for that matter, are the likely source. The new observations using 2 of the outriggers suggest the source of FRB 2024-0209A could be in a globular cluster, a dense region of old dead stars outside the galaxy. Now, if confirmed, it would make this fast radio burst only the second to be linked to a globular cluster. However, the other FRB originating from a globular cluster was associated with a live galaxy, not an old elliptical dead one, in which star formation had ceased billions of years ago. So once again, the universe is proving to science that it's not just stranger than we imagine, it's stranger than we can imagine. This is SpaceTime. Still to come, is the red planet Mars still geologically active? A new Australian-based study suggests that it is. And Southern Hemisphere sky watchers experience a real astronomical treat. All that and more still to come on SpaceTime. A new study has raised the possibility that the red planet Mars is still geologically active. The findings, reported in the journal Geophysical Research Letters, are based on a new analysis of a series of Marsquakes recorded by the seismograph aboard NASA's Mars InSight lander. One of the study's authors, Professor Hidove Talzic from the Australian National University, says Marsquakes, which are similar to earthquakes, could offer clues about how the red planet evolved over billions of years. The findings could help explain why the red planet's southern hemisphere has a thicker crust and is between 5 and 6 kilometres higher in elevation compared to its northern hemisphere, a phenomenon known as the Martian dichotomy. In fact, the difference in topography between the two Martian hemispheres is similar in height to the highest mountain ranges on Earth. This difference between the two regions was likely shaped by convection, the transfer of heat from one place to another in the Martian mantle over hundreds of millions to billions of years ago. The mantle is the inner layer of Mars, sandwiched between the crust and core. Talzic says the difference in the red planet's hemispheres is one of the biggest mysteries in the solar system. He and colleagues analysed waveform data from low-frequency Marsquakes captured by the InSight lander. And they located a cluster of 6 previously detected but unlocated Marsquakes in the planet's southern highlands Terra Cimmeria region. Now, the data from these Marsquakes, when compared with the well-documented Northern Hemisphere Marsquakes, reveal how the planet's southern hemisphere is significantly hotter compared to its northern counterpart. Talzic says understanding weather convections taking place offers clues as to how Mars has evolved into its current state over billions of years. He says there are 2 competing hypotheses to try and explain the origins of Mars's dichotomy. The first, referred to as the endogenic hypothesis, states convection in the red planet's interior formed the dichotomy. The second, known as the exogenic hypothesis, believes astronomical events shaped the planet's hemispherical differences. In other words, the northern lowlands were caused by a big asteroid impact. These new research findings provide the first observational evidence supporting the endogenic hypothesis. But just getting there has been a real feat. See, on Earth there are thousands of seismic stations scattered all around the planet, so it's easy to triangulate exactly where a specific earthquake took place. But on Mars, there was only ever the one single seismic station, InSight, which operated between 2018 and 2022 when dust covering its solar panels finally brought the mission to an end.
Our findings have 2 particular aspects, and the first one is that we discovered new locations for already identified Marsquakes that were available in the Marsquakes catalog, but their locations were not known, and we identified a cluster of 6 Marsquakes in the southern hemisphere of Mars, namely in the southern highland. And secondly, we compared the characteristics of the seismic waves propagating from those new Marsquakes in the south of the InSight lander with those from the Marsquakes that were relatively well documented from the north of that lander. And we found the differences in the way these seismic waves propagate, which we attributed to the differences in the temperature between 2 sides of Mars, south and north of that dichotomy border.
We know that our own moon still has a semi-liquid core. Do your findings suggest that the same could be happening on Mars, that there may still be some degree of fluidity in the Martian core, or at least in the core mantle boundary area?
Well, that's a good question, but I wouldn't go that far to interpret the Martian core based on our data. Although what we find is that the thermal differences exist between the 2 hemispheres that are significant, and that's based on our measurement of the so-called seismic attenuation, the way that the seismic wave energy weakens as the seismic waves are moved through the Martian interior. So the temperature difference is significant, and remember that the Mars doesn't have the plate tectonic. So If anything, then it's really just the thermal factors that contribute to the Martian dynamics, as opposed to the Earth, where you have both compositional and thermal effects. So I wouldn't go that far to interpret the Martian core yet based on these findings, but there are seismic data that suggest that the Martian core is in a liquid state indeed.
A lot of Marsquake data that we've received from InSight has resulted from asteroid impacts on the Martian surface. Other data has resulted from the Tharsis region, where we know there's been volcanic activity in the geologically recent past. So it all seems to be pointing to Mars still being geologically alive, at least to some degree. Does that correspond with what you're finding in this new data from the Southern Hemisphere?
It might as well be. I mean, we had another paper a couple of years ago where we found repetitive Marsquakes, which are very similar to what happens under some volcanoes on the Earth. And our conclusion back then was that Mars might have a mobile interior based on that behavior of the repeating Marsquakes. But you also mentioned the meteorite impact. And interestingly, in this particular work, we use meteorite impacts as sort of ground-truth locations to test our method. In other words, how well we can actually locate these new or previously documented Marsquakes for which the locations were not known. So when we applied a method to these meteorite impacts, we were able to demonstrate that our locations are very close to the locations of the impacts that were recorded by orbital cameras, and therefore we can use them to test our method. So meteorite impacts are extremely useful to us, not only to verify the methods, but of course, they also generate seismic waves that ripple through the Martian interior and are eventually recorded. So they are extremely useful to us.
What sort of things would cause the Martian dichotomy that we see on the red planet? We have a very broad, mostly flat northern hemisphere and a higher altitude, mountainous and rugged terrain southern hemisphere. What sort of things cause that?
Well, as you probably know, there are two existing hypotheses on that are competing hypotheses, and I would say that our research and our newly published paper is the right step in the right direction. But I would say that debate will still going on for a while. So just to remind you, the so-called endogenic cause would mean that the debate was generated by the internal forces of Mars, perhaps a different style of convection in the past that was frozen and that manifests itself as the Martian dichotomy. And that means not only the difference in the elevation, which is quite striking, 5 to 6 kilometers between the north and the south, but also the thicker crust in the south, and also the evidence of magnetized rocks in the south, whereas the northern part seems to be lacking that signature. So that's the endogenic hypothesis. And then, of course, the exogenic, that the dichotomy might have resulted from either a giant impact of or a series of smaller impacts from space in the past. So these are the two existing and the two competing hypotheses. And our findings are very much in line with the endogenic cause, or the internal forces within the Mars that generated and shaped the dichotomy that we see today.
What would you like to see happen next?
That's not very difficult to guess. I would like to see more landers carrying a seismometer. We've seen from InSight that it is with the careful planning, it is really possible to get outstanding data sets, almost 4 years, about 1,300 Marsquakes, if I'm not mistaken. So I would say that InSight really is a prototype for future missions, and I would really like to see more data on the Martian surface, not just seismological data, but any sort of geophysical and astronomical instrument or equipment you can imagine. This cluster of 6 events that we found in Terra Cimmeria has been previously identified in terms of Marsquakes occurring and being recorded, but they were not attempted to be located because the data quality is quite poor. And so what we have done differently here, we introduced several methods that are readily used in exploration seismology here on Earth. And when we apply these methods to the location, because as you know, we cannot perform a triangulation on Mars. We don't have more than a single instrument. So we have to be innovative in the way that we locate Marsquakes. And when we apply these methods, that allowed us not only to locate the cluster of 6 Marsquakes in Terra Cimmeria, but also to estimate the uncertainty, I would say, in a more robust way because we applied several methods.
That raises a good question. How does one triangulate a location when you've only got one collection point?
Sure, that forces you to be very innovative, and I should say that we do that on Earth as well in some remote areas where we have, let's say, a very small earthquake and a single instrument. So the first thing you need to do is to identify both P and S waves. So the compressional and the shear waves. Compressional waves move faster than the shear waves. So from the difference between the two and knowing how quickly they move through the Earth's interior or the Mars interior, you can determine the distance to an earthquake. But that's just the distance. It can be anywhere on a circle, and normally you would use several instruments to triangulate. But in this case, we have to rely also on the ground motion, and from the ground motion, the direction of the particles of the ground and how they move when the seismic waves pass through, we can also determine the azimuth or the so-called back azimuth of an earthquake. And this is basically the method that is used. So determine the distance from the difference of P and S waves and determine the azimuth or the back azimuth based on the ground motion.
That's Professor Hidove Taujic from the Australian National University. And this is SpaceTime. Still to come, the Southern Hemisphere sky watchers get an astronomical treat, and later in the science report, a rare corpse flower has burst into bloom in Sydney's Royal Botanical Gardens. All that and more still to come on SpaceTime. Sky watchers in the Southern Hemisphere are enjoying a celestial spectacular right now, with the Comet C 2024 G3 Atlas putting on a stunning display following its close encounter with the Sun last week. The bright comet surged through images taken by the joint NASA European Space Agency Solar and Heliospheric Observatory spacecraft SOHO. Atlas made its closest approach to the Sun, perihelion, on January the 13th, soaring a mere 13 million kilometres above the solar surface. That's just 9% of the average Earth-Sun distance, and exposes the icy comet to incredible amounts of heat. And that releases lots of volatile gases, increasing the size of its coma and tails. Images of the close encounter were captured by SOHO's large-angle and spectrometric coronagraph instrument LASCO, which uses a disk to cover the Sun's surface, revealing the finer details of the solar atmosphere or corona. The comet was first detected back in April last year by the Asteroid Terrestrial Impact Last Alert System or ATLAS survey. LASCO's helped discover over 5,000 comets as they fly past the Sun. Carl Badams, LASCO's principal investigator at the United States Naval Research Lab in Washington, D.C., processed some of the images to bring out finer details of the comet's tails. When bright comets like Atlas pass close to the Sun, their tails often react to fluctuations in the solar wind, the constant stream of charged particles flowing out from the Sun. Heliophysicists can study the reaction of the tails to better understand the Sun's effects on its neighbourhood and comets passing nearby. While it was briefly visible in the northern hemisphere skies just after sunset near perihelion, Comet Atlas is now slowly receding from the Sun, and is best seen from the southern hemisphere, where the comet's moving into darker night skies, and it's proving a spectacular sight just above the horizon. However, there are signs starting to appear that the comet may have broken up following its close encounter with the Sun. And if that is the case, it'll probably fade rapidly in coming days. Now, adding to the display was the sight of no less than 6 planets from our solar system all lining up together as seen from Earth. This wonderful planetary parade included Venus, Mars, Jupiter and Saturn, all visible to the unaided eye this month and for the start of February. Meanwhile, Uranus and Neptune can also be spotted, but you'll need binoculars to do that. And faint Mercury is set to join the parade as a bonus 7th planet at the end of February. All in all, a spectacular time to study the night skies. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. Scientists have developed a new class of anti-clotting blood thinning drugs for patients with atrial fibrillation. Atrial fibrillation is a persistent non-rhythmic beating of the heart that causes turbulence within blood vessels, and that can lead to blood clotting. The new drug appears to work significantly better at reducing bleeding events compared to the standard treatments. People with atrial fibrillation are typically prescribed anticoagulants or blood thinners in order to reduce the risk of a stroke. But many discontinue them or never receive the prescriptions due to concerns of an increased risk of bleeding complications. Put simply, if you're on one of these drugs and you cut yourself while shaving, it never heals. Now, a report in the New England Journal of Medicine has evaluated a new class of anticoagulants known as factor XI inhibitors, finding that abelacimab significantly reduced bleeding compared to a standard of care anticoagulant, rivaroxaban. See, the problem is the risk of stroke increases significantly in patients with atrial fibrillation because blood clots form in the heart chambers, and these can be pumped to the brain, causing a stroke. The authors enrolled 1,287 participants from 95 study sites around the world. They found that a 150 milligram dose of abelacimab reduced bleeding that required hospitalization or medical attention by 62% compared to rivaroxaban, and a 90 milligram dose reduced the same types of bleeding by 69%. More than 20,000 people have lined up in Sydney's Royal Botanical Gardens to get a glimpse of a rare corpse flower which has finally burst into bloom. The endangered plant, whose scientific name is Amorphous titanum, has the biggest, most pungent flower spike in the world, and it smells like old wet socks or rotting flesh while blooming. The plant, which is native to western Sumatran rainforests, only blooms once every 15 years, and that bloom only lasts between 24 and 36 hours. The plant normally thrives in shady, moist and warm conditions at about 22 degrees Celsius and 75% humidity. Estimates suggest there are less than 1,000 specimens left in the wild, and so samples have been placed in botanical gardens around the world in order to keep the species alive. This is the fifth corpse flower to bloom at the Sydney Gardens and follows predecessors in 2010, 2008, 2004 and a double bloom in 2006. The US Food and Drug Administration has finally announced a ban on red dye number 3, a controversial food and drug colouring long known to cause cancer. The chemical, which is also known as euthorazine, has long been banned in most countries but has remained in use in some 3,000 food products in the United States. The long overdue decision follows decades of scientific evidence. In fact, back in 1990, the FDA determined that red 3 should be banned from cosmetics because of its link to thyroid cancer. However, the additive continued to be used in foods, largely due to strong resistance from the food industry in America, such as the manufacturers of maraschino cherries, who relied on red 3 to maintain the iconic red hue of their products. It's also used in thousands of candies, snacks, fruit products and medicines. The European Union banned its use in 1994, with similar prohibitions enforced in Australia, Japan, China, the UK and New Zealand. However, even now, the American ban won't be immediate. Manufacturers will have until 2028 to reformulate their products. United States studies show that global trust in news organizations and mainstream media reporting has now reached its lowest level for decades in the developed world. A 2024 Gallup poll has found that the legacy news media is the least trusted group among 10 US civic and political institutions involved in the democratic process. And of course, it's not just America. Here in Australia, we've seen how the ABC lied to the public in their reporting of the Heston Russell case, where they've been forced to pay $390,000 in damages, that's taxpayer money of course, to the former highly decorated Army commando after they deliberately fabricated their story. Then there were the false allegations made by the ABC against George Pell, who was later found to be completely innocent by the High Court of Australia. And of course, there was the ABC's 3-part Trump-Russian collusion hoax story, which the FBI found to be untrue and invented by lawyers working for Hillary Clinton to take attention away from a classified email scandal. And it's not just Australia. It's the same all over the world. The BBC, CNN, MSNBC, The Washington Post, The New York Times, Al Jazeera, PBS, NPR, the list goes on. All are losing ratings and subscriptions because the public now know the mainstream media are not telling the facts. They're not letting the truth get in the way of a good or politically biased story. Instead of reporting just the facts, with balance and without bias, and then letting the public make up their own minds, these days journalists are editorializing their stories, telling the audience what they should think and why. But with the dawn of social media providing so many different perspectives and exposing traditional mainstream media's lies, trust in legacy media has been badly eroded, and in fact, it looks like it may now be gone for good. Tim Mendham from Australian Skeptics says this is not new. Mainstream media's credibility has been diminishing for years.
Mainstream media might recover by telling the truth.
That'd
might
be a
an
nice
interesting
change.
concept. Yes, I mean, media is biased from 2 points of view. It's obviously, it can be biased because of the just political and social leanings of the management and the people who work for it. And that means everything they say.
Media's always been biased. It's only we had this unique period in the 60s and 70s where the bias stopped for a while, but it's come back. It's come back with a force.
It'd be nice if it stopped entirely either way. The second thing is the natural inbuilt bias to reporting in journalism, where you can't possibly report everything within a story. You can't report every story for a start, and you can't report everything within a story. So there's a selective nature of reporting. It's just inbuilt. There's nothing you can do about that, and the question is, what do they keep in, what do they keep out? Hopefully they keep in the most pertinent bits, but not always. Sometimes they keep in the bits that sell a story, and they leave out the unnecessary detail that sort of counteracts what they're trying to sell. So people don't trust what they see in it because they don't believe it. They don't believe it because they're told not to believe it, or they don't believe it because they've had personal experience and they know how wrong a story can be. Most of us who have been interviewed for a story know there's always a mistake there somewhere.
Yeah, you don't want to see how the sausage is made, do you?
Not particularly, no. I mean, most people only see the outcome of journalism. They never see how a journalist works.
For me, the BBC lost all credibility. When I was working at the ABC, I was the night anchor on News Radio, and we had this one story. I forgot if it was from Reuters or AFP, but it was a Wires story, and it simply pointed out that the crews aboard the Royal Navy ships in the Gulf War had asked and their captain had agreed to it, had asked their commanders to switch from the BBC coverage to the Sky News coverage. This is UK Sky News, not the Australian version. And the reason they did that was because what they were experiencing in the Gulf War didn't match what the BBC were reporting.
Yeah.
And when ground truth doesn't match what you're seeing or hearing or reading, then that's when credibility goes. And you can almost never get that back.
Yes, I agree. There's also a very common thing these days, of course, with the electronic media and TV, 24-hour news and the online news, that people have to get a story out there as quickly as possible to beat the opposition. And that means a story can run without proper checking. It happens all the time, of course, and it happens a lot with social media and things like that. A rumour is as good as a reporting story, apparently, and it just runs. And often it's hard to counteract even when you find out the truth. So there's major issues always with journalism. It's been increased with technology. There's also been increased because of this technology with approaches by journalists who want to make their name or something. One is what I call the shark pack, which means one journalist takes an attitude towards a particular story and everyone follows it, regardless of how true that original approach is. The other one is the classic gotcha moment, where someone sort of throws in a curly question, and if you can't answer
how
it,
much is a loaf of bread or a pint of milk?
Well, whatever, things like that, and if you can't answer it straight away, you fumble and mumble, and you look at sort of like, this person doesn't know anything. It's futile. It's pointless.
But you know how you get over that. And I've been in a situation where I've been live on air, and the anchor of the show asked me a gotcha question like that, and I simply tell them, look, I don't know. I'll have to get back to you on that. It's really simple. It doesn't make you an idiot.
Yeah. There are a lot of journalists who are quite sincere, try and do their work. They're stymied in many ways, especially these days with journalist numbers being cut back, and therefore each journalist has to do a lot more stories.
Yeah, so the court reporters also doing science reports, which they're not simply don't know anything about.
They've always had that, though. Yeah, so at certain areas you have few journalists who are qualified to do something. But anyway, some people suggest, almost naively, I had a story in front of me by a professor of media studies, journalism, suggesting that one way to restore trust is by what he calls solidarity journalism, which actually means going to the source of information and treating them respectfully and hearing their point of view, rather than coming in for a fly-in, fly-out sort of story, reporting and often taking the most sensational approaches. All well and good, but in the 24-hour news cycle, 5-second grabs, shortage of staff That's a nice ideal. And unfortunately, it doesn't work, which means that journalism is having a hard time, which means people don't trust journalists. Then again, people haven't trusted journalists for a long time. They've been put in the same basket as
used car salesmen.
Used car salesmen and politicians, basically. So they're tarred with that brush. And to get over it, tell the truth simply, straightforward.
It's very sad when you think of how often credible journalists have died because they put truth to power.
Yeah, absolutely.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.